Hello everyone, thank you for joining us today as we dive into a truly groundbreaking project. I am excited to present to you an innovative solution developed by our team geekyKnightz in response to the Government of Gujarat's call under the theme of blockchain and cybersecurity. Our project aims to revolutionize the way government organizations and educational institutions handle certificates and credentials. Now, before we get into the nitty-gritty details, we have all heard stories about folks trying to Photoshop their way into success by faking certificates and qualifications, right? Well, here is the kicker. We have some bad news. We are about to introduce something that's going to make their lives a lot more challenging. So brace yourselves, because our team has brought innovation to the table. Our team Geeky Knights, led by Mayuk Mandal and team members Swantan Maji, Vraj Shah, Ayan Kanti Das, Anish Chattopadhyay, and Sambhavi from Kalinga Institute of Industrial Technology, is proud to present this solution. The problem statement is titled Online Blockchain-Based Certificate Generation and Validation System for Government Organizations. Now the idea. Our solution envisions a robust and user-friendly blockchain-based certificate generation and validation system which will enhance transparency, security, and efficiency in the certification process. Imagine a system where custom digital certificates can be generated to meet the unique needs of government offices, students, industries, and institutes. These certificates are not just ordinary documents, they are integrated with blockchain technology. Each certificate is time-stamped and linked to a secure blockchain network, making them immutable and traceable over time. Users can conveniently store their digital certificates in a secure digital locker. What sets our system apart is its ability to validate certificates with ease. Government offices and educational institutions can verify the authenticity of certificates through a blockchain-based validation process, thereby reducing the risk of fraudulent claims. And our solution is built on a solid technology stack, including HTML, CSS, JavaScript, React for the web interface UI, and Python with Flask framework for backend hosting. We employ OpenCV for image recognition, cryptography for RSA encryption and SHA-256 hashing, and QR code generation using Python. All data is stored efficiently in a SQLite 3 database. Now the architecture. The process begins with the entry of user details on the admin side. These details include information related to the certificate that needs to be generated. After user details are entered, the system initiates the certificate generation process. During this step, the user's information is encrypted using public-private key pair. This encryption ensures that the data is secure and only accessible to authorized parties. The system then integrates blockchain technology and uh, a decentralized and secure ledger into the process. It generates a current hash from the encrypted user information and the previous hash by adding this data to the blockchain. In blockchain terminology, this forms a new block containing encrypted user information, the current hash, and the reference of the previous hash. The blockchain ensures the immutability and traceability of the certificates over time, making it tamper-proof. To maintain the blockchain data, the system stores it in a database. This allows for efficient retrieval and validation of certificates in the future. The system creates a QR code from the encrypted data generated. This QR code will serve as a convenient and secure method for accessing the certificate. The generated QR code is added to the certificate along with some required user details, completing the certificate for download. The certificate is now ready to be issued to the user. On the user side, the process begins when they upload the certificate along with their input, which corresponds to the user details provided during the certificate generation. The system scans the QR code present on the certificate to retrieve the encrypted data. The system checks for the presence of the encrypted data in the blockchain database. If the data is found in the blockchain database, the process proceeds to decryption using the user's private key. This decrypted information is then compared to the user's input, ensuring that the certificate matches the original data. If the fields match, the certificate is validated as authentic. A query is sent to the generation server to obtain the current hash of the encrypted data block, which is printed as a signature in the certificate. The validated certificate is returned to the user for download. If the fields do not match, the certificate is considered invalid. And again, if the encrypted data is not found in the blockchain database, the certificate is deemed invalid. This architecture ensures a secure, transparent, and highly efficient process for certificate generation and validation system. The use of blockchain technology guarantees the integrity of the certificates and minimize the risk of fraud, making it a valuable addition to the government organization and educational institutions.
Our project is a pioneering solution that leverages the power of blockchain technology. It's a testament of our unwavering commitment to redefine trust, security, and innovation in this digital era. Now, I'm excited to dive into the use cases that truly exemplify the transformative potential of our project. From the healthcare sector, where we can validate medical licenses and certifications, to academia, where universities can issue and verify digital diplomas and degrees. Our system is a versatile tool for ensuring authenticity and reliability. In the professional realm, we can streamline the process of validating resumes, enhancing trust in the hiring process. Government documents, cash memos, and art pieces, everything will become more secure and verifiable with our system. But we didn't stop there. Our project extends its impact to a multitude of industries, offering solutions for supply chain verification, notary systems, food safety, environmental certifications, intellectual property protection, etc. Now, as we have explored the transformative use case of our project and unveiled its remarkable features, I'd like to take a moment to underscore the broader implications of what we're building. Our project is not just certificates and use cases, it's a paradigm shift. The decentralization we've incorporated ensures that no single entity has complete control, providing the foundation for unshakable trust and transparency. Our system is a highly secure standalone solution built from scratch, leaving no room for external vulnerabilities or dependencies on third parties. Versatility is in its DNA, with cross-device support that's designed to make accessibility a universal reality. But perhaps the most compelling feature is the anti-breach system, rooted in blockchain's ability to remain unchanged, unaltered, and memorable. It renders any form of fraud impractical. As we wrap up our presentation, I'd like to emphasize that our project offers not just technical innovation but also substantial financial potential. Monetization strategies. We're exploring innovative monetization strategies. This includes offering a customizable admin interface as a licensed product, providing organizations with tailored administrative solutions. We're also planning to monetize our validation system as a service, offering cloud-based certificate validation through subscription models. Market potential. It's crucial to consider the market potential. The global e-learning market is set to reach $370 billion by 2027, with a CAGR of 8%. The global blockchain technology market is projected to grow at a CAGR of over 51%, reaching $39 billion. The market for secure document management is also on the rise. Our monetization strategies align with these trends, creating opportunities for substantial revenue. We're not just offering a solution for today. We're presenting a vision for the future where trust, security, and financial stability converge. In conclusion, our project, the blockchain-based cyber certificate generation and validation system, stands as a testament to innovation, trust, and the limitless potential of technology. We walked you through our potential, powerful use cases that addresses critical challenges. We've showcased the technical depth of our solution. We've explored the promising market potential and monetization strategies that underscore the sustainability of our project. But this is not just a concept, it's a reality. We have a working prototype embodying our vision in code and functionality. Ladies and gentlemen, our project is more than just technology. It's a transformation of how we perceive trust and security in the digital age. It's a commitment to shaping a future where authenticity and innovation converge seamlessly. We stand here not just with an idea, but with a tangible solution, a technical foundation, and a business plan that aligns with market trends. We're not just asking for a recognition, we're offering a partnership in building a future where trust knows no bounds. Thank you for your time, and we look forward to the opportunity to take this journey together. Your support will not only advance our project, but also provide trust and security into the future.
Moving on to our working prototype, we have two main functional components. The generation web page, which will be proprietary to the institutes or managements in charge of issuing the documents or certificates. The validation web page, which enables the certificate holders to upload their certificates whether in digital format or as scanned copies, issued by the institute for verification and storage. This web page is designed to seamlessly integrate with the DigiLocker. Now, coming to the generation web page, when we use the generation web page, the management team will need to enter the necessary details of the certificate holder to generate the certificate. A portion of the details provided by management will be printed on the certificate template, customized according to the specific requirements of the management. For example, here we need to enter our name. Here I'm entering my name, any email of our choice, any contact number, then course ID. For example, over here putting CSE, institute, city, then any start date and end date. Yeah. And then we need to click on the generate now button to generate the certificate. Then after generation, we can download the certificate in PNG format by clicking the download certificate button. Now, as we can see the certificate, some specific informations have been added to the certificate template along with a QR code. Now, the QR code contains all the information provided by the management in an encrypted string format, which consists 1024 characters to ensure utmost security and integrity. And all the information gets added to the blockchain present in our database, which will again be proprietary to the management. So over here, now we can observe a sample of our database. The data is added in the encrypted string format. Over here, this is an example of our data, along with the timestamp of its generation. Additionally, the hash code of the previous block is added, and all these elements are together are hashed to create the current hash. This current hash will later be used as a digital signature on the verified certificate. Now, this ensures that the data stays unchanged. Once the certificate is issued, the data within cannot be modified. If any changes are made to the database, the blockchain becomes invalid and the data becomes locked. This decentralization is an important feature. Now, coming to the validation part. Now, let's consider a scenario where the certificate holder possesses the certificate and wishes to have it verified and stored in the DigiLocker. This way, other institute can recognize its authenticity. Now, the certificate holder needs to enter all the necessary information exactly same as the institutes to get the certificate verified. So over here, I'm doing the same. I'm just copying and pasting the details. The email, yeah, and now we need to choose the certificate. Over here, I have that in downloaded files. Okay, now we upload the certificate and click on the verify button. As we click on certificate and click on verify button, it sends an API query to the server of the management to check if the encrypted data in the QR code is present in the blockchain database or not. If the data is present, it proceeds to decrypt the data using the private key and verify each and every field. If they match, the current hash of the block containing the details of this specific certificate is displayed as a digital signature. For example, we can see, yeah, now this is digitally verified. So if any discrepancy is found, it will not verify the certificate. As we can see over here, I have put all the data exactly same as the one in the generation server. But if we change any minor detail, for example, I'm just changing some characters of my name and click on upload and validate. The validation failed and certificate will not get validated. Therefore, if someone tampers with the details based on the certificate and fails to provide the exact required details present that in the blockchain, it won't get verified and signed. As a result, it won't be stored in the DigiLocker and cannot be viewed by other institutes. I hope you liked our project. Thank you for viewing.